my name is Anika Cho and I'm an undergraduate student at the University of Alabama. This summer, I'm working with Dr. Dorgan here at the Dorgan Lab.
For my project, I'm working on a DIY instrument that measures the fracture toughness of marine sediments. Fracture toughness is a quality that describes a material's resistance to crack propagation. We're interested in developing methods of measuring this because we want to know more about the biomechanics of burrowing. Animals that burrow through ocean sediments, like worms, are ecosystem engineers that shape their surroundings through important ecological processes like bioturbation. Worms extend their burrows by fracturing the mud in front of them, and their burrowing behavior depends on material properties like fracture toughness. This project will help us understand more about how the marine sediments that cover 70% of the Earth's surface are being affected by burrowing activity. The questions I'm trying to answer this summer are: how does fracture toughness vary across natural sediments and depths? And how important is hydraulic pressure in burrow extension by fracture? To answer these questions, I've been working on this instrument, which uses a stepper motor to inject specified volumes of air through a dispensing needle until a coin-shaped bubble forms in the material sample I'm testing. I'm using an Arduino Zero and a tiny G CNC controller board to control the motor, and I've coded a few different cases that vary the volume and speed of air injection. I've also hooked up a pressure sensor so that I can see what the peak pressure is before fracture occurs and a bubble forms. From the pressure values, which get logged to an SD card during testing, I can see when the bubble formed and calculate fracture toughness. For my project, I've been collecting sediment cores, which are vertical profiles of marine mud from a marshy coastal area called Point of Pines. I keep them stored and oxygenated in the wet lab until I'm ready to test them. I'm testing each of my cores with the bubble injection method and this fracture probe method, which my mentor previously developed. This instrument corkscrews down into the sediment and then tugs up to try to break off a plug of mud. A sensor measures the force it takes for the plug to break off, and we can calculate fracture toughness from that value. Previous fracture probe results show that it gets harder to fracture sediments at greater depths. If this is true, that would mean worms deep in the ocean floor have to work really hard to extend their burrows. However, the fracture probe doesn't account for the hydraulic aspect of burrowing.
Worms pump water as they burrow. The bubble injector that I've been working on uses fluid pressure to measure the fracture toughness of different sediments. So we think that it's a better model of burrowing than the fracture probe. So I'm interested in comparing the results of these two machines at different depths.